Okay, we are on part 3 of section 4.4. We're going to now look at the derivatives of log functions. So we were doing exponential functions, and now we're going to be looking at essentially the inverse of an exponential is a log function. So goal would be, if we have some function, start with natural log. Okay, my video cut out for just a second, sorry. So we're picking up with, here's our goal, is find the derivative of some function natural log of x. So let's actually consider that function. And so far I've not taught you any rules for finding the derivatives of a log. So my thought would be, let's actually turn it into something besides a log. So can we convert that? And we should be at least vaguely recalling a process that we use to convert a log into an exponential. An equivalent form of that equation would be to say that e to the y is equal to x. So I'm going to take that equation and I'm going to say, can I take the derivative of this? I like it better because we just spent some time looking at derivatives of exponentials. So let's see what we can do if we differentiate that implicitly. So derivative of the left-hand side, I've got e to a power. So derivative of e to a power is e to that power times, if that power is something besides x, du dx, but in this case, dy dx. Since I don't have a u, I'm not going to rename my y u. So e to the y times dy dx is equal to derivative with respect to x of my function x, which is just a 1. Let's solve for dy dx. This is going back to section 4.2, my implicit differentiation, and all I need to do is divide by e to the y on both sides. And I get 1 over e to the y. So I've got dy dx is equal to 1 over e to the y, but go back to my original conversion. And my original conversion right here, we said e to the y is equal to x. If you get rid of the d dx's there, e to the y is equal to x. So I'm going to take this e to the y, and I'm going to replace that with x, because that's really just x. So my final answer then would be derivative with respect to x of my natural log of x is really just 1 over x. Now that's a pretty nice rule. What we have established is natural log of my function x, derivative will always be 1 over x. We should be able to change that to be an appropriate differentiation rule for natural log of any function, not just x, because we know that that could be a function in there. And based on what we've done with the chain rule so far, we should be able to see that that's going to be 1 over u, and then I'm going to have to follow that by du dx, derivative of my function with respect to x. So those are your 2 new rules. You can think of it as one rule, but I know it changes a little bit when I have to apply the chain rule. Let's look at some examples and see how we do with it. So, example 1, let's consider the function y equals natural log of x squared, and just to clarify, that's going to be x squared is inside my natural log function. So I'll go ahead and write it out if it helps you to see it this way. My u is going to be my x squared, so du dx is equal to 2x. When I go to do my dy dx then, it's going to be 1 over u. So applying my rule, I know my rule is not written here anymore, but you should have your rule on your paper. 1 over u, and my u was x squared, times my dy dx, which is 2x. I will jot the rule down just so you can see it. Derivative of my natural log of u was 1 over u times du dx. So du dx was 2, and then this 1 over x squared was my 1 over u, since my u is x squared. Just to simplify that up, that's the only thing we need to do here. I've established I have 1 over x squared times 2x, which is 2x over x squared. And I can, of course, cancel the x and the squared, giving me 2 over x. Okay, so that's what it's going to look like. Let's do a few more examples. Let's say that we have the function y equals natural log of x squared. Notice the difference here. I still have squared, but I don't have x squared inside my natural log. I have natural log of x quantity squared. So, if I'm looking at this one, I'm now going to say that my u, my inside function, is my natural log of x. And natural log of x, derivative of natural log of x is 1 over x. My function itself is u squared, so dy du is 2u. I thought it might be helpful to write out the whole thing here. So if I'm talking about my chain rule, is going to be dy du times du dx. So my dy du is this 2u, and then my du dx is 1 over x. So final answer here, my derivative with respect to x of my function y is 2 times u is natural log of x, all times 1 over x, which I'm just going to write as x in the denominator. Okay, I did my full u substitution there just to show you the whole chain rule written out. Let's do 2 more examples. So this is a crazy looking one. What if I have y equals natural log of the natural log of x? Like when we have a trig inside of a trig function. Let's go ahead and write it out. So I'm going to make my u equal natural log of x. That's this natural log of x. Du dx is equal to 1 over x. That's the same as what we just had. Difference is that my y function is natural log of u, because my outside function is natural log of something. Oops. And my something this time is my, what I've called my u. So dy du is going to be natural log of u, which is 1 over u. So when I write this out, of course, going back to my chain rule, dy dx is equal to dy du times du dx gives me dy du is 1 over u, du dx is 1 over x. Of course, I need to make my substitution here. So my final answer is 1 over u is the natural log of x. So I'm going to substitute that in times 1 over x, and I'm going to write that as 1 over x natural log of, whoops, it's supposed to be an x, 1 over x natural log of x. That's going to be my final answer there. Okay, let's do one more. So this time let's do y equals, whoops, x times natural log of x minus x. And I've simplified my log function to just natural log of x, but I have thrown in a product rule there. So you should be recognizing that we have 2 functions. We have x times natural log of x. So I'm going to start with my product rule, which is going to be my first function, x, times my derivative of my second function. I have not taken the derivative yet. I'm just writing out what I'm going to do, plus my second function, natural log of x, times my derivative of my first function. So that's my product rule. All of this is for the derivative of my product of two functions. Don't forget about this minus x at the end, and that's just going to be minus the derivative of x, which is 1. So let's go back and actually do the derivative. Derivative of natural log of x is 1 over x, and derivative of x is just 1. So I have x times 1 over x plus natural log of x times 1, and then I've got this minus 1 at the end. X over x, because I've got x times natural log, or x times 1 over x becomes x over x, plus natural log of x times 1 minus 1, and this of course simplifies to just 1, so I really have 1 plus natural log of x minus 1, and then the 1's cancel, 1 minus 1 is 0, so final answer here, natural log of x. That's a pretty sweet answer. So sometimes things simplify nicely, and I am liking that one a lot. Hopefully that helped to have some examples for how do you do logarithmic differentiation.